Right, so we're going to continue to the next chapter now. We're going to go to chapter 4. This is still descriptive statistic, but instead of what we learned in the past, describing a single variable, now we're going to describe relationships between variables. And of course, we focus on the easiest relationship, linear relationship. So scatter plot and correlation. Again, anytime when we talk about a new concept, please refer to this diagram. Right now, we're still doing descriptive statistic, right? But we're doing this describing relationships instead of describing a single variable. Right, so please make sure you get familiar with all the symbols we talked about, especially the ones we really learned. Little by little, we're gonna learn all of the symbols, and you're gonna have all formulas, related to the symbols. So let's go through the list real quick. So small n, anytime you see a small n in statistics, that's referring to the size of the sample size. How many individuals are there, right, in the sample? And the big N is always population size. So for the population of interest, how many individuals are there, right? This is sigma. Sigma is population standard deviation. And then S, this is also standard deviation, but this is standard deviation of the sample standard deviation. Mu is population mean. So it's the average of the entire population versus X bar is sample mean. Okay. So we already learned N as an X bar, right? Okay, Z is standard normal variable. We're gonna learn this in normal distribution. And then R, we're gonna learn R today. This is called a correlation. And B1 is regression slope, and B0 is regression intercept. And this is a y-intercept. P-value and alpha, they're both used in hypothesis test. P-value is a probability. What kind of probability? It's a probability of observing a sample as extreme or more extreme than the sample being collected. So basically, this is a probability of, observing something more extreme or extreme than the sample you collected. How likely are you able to get the sample that you get if you're doing a random sample? Right, so alpha is type 1 error rate. So by comparing p-value and alpha, we're able to make a statistical decision, okay? So please get familiar with all the symbols. So the chapter title is scatter plot and correlation. The learning objective basically just we need to know how to make a scatter plot, how to interpret the scatter plot. Also, how do we calculate the correlation and how do we interpret correlation? Keep in mind, a correlation is used to describe just the linear relationship between two variables. We have all different kind of relationships, like what you learned in the math class. For any kind of function you learn, that's basically a relationship. For example, you have, linear relationship, y equal to mx plus b. You have a square relationship, y equal to x squared. And you have a square root relationship, like y equal to square root of x, or exponential relationship, or log function, log relationship. So there are all different kind of relationships. But the linear relationship is the easiest relationship out of them, and we are focusing on just the easy relationship, and that's what people study the most also. So we're going to start with the scatter plot. So scatter plot is a graph. We can use scatter plot to describe a relationship. So how do we make it? It's pretty simple. You guys have learned the axes. X-axis and the y-axis give you XY plane. And then for any point, you can, in the plane, you can use the coordinate of X and Y values to locate it. So that's the idea. So basically, when you have a sample data, and every individual have two measures. One is X, the other is Y, and those two measures will serve as a coordinate of that individual in the XY plane. Then every individual will have a location. Then, once you put every individual in the XY plane, then you have your scatter plot produced. And that's pretty simple, right? So then let's look at an example. So here there's a research. They want to see if heavier people will burn more energy. And, common sense, I think it's true, right? So then in a study, they measure metabolic rate and the energy and the person's mean body mass from 10 individuals. And here, particularly, they want to study women. So we have a data set, the lean body mass and the metabolic rate. And, this is variable X, this is variable Y. And we want to see the relationship. When you look at the number, it'll be hard to see if they're related, right? We can kind of see some trend, but it's too hard. So we need to, observe the relationship very quickly. So a good approach is to draw a scatter plot. So then how do I draw a scatter plot? Let's look at, example here. So when you draw a scatter plot, first you need to prepare the axes. You have x-axis as the mass and the y-axis as the metabolic rate. And by looking at a range of values, you can see y is between 995 up to 1502. So you need to make sure your axis is labeled accordingly to cover the range. And for x-axis, as small as 33.1, and biggest is 54.6. So make sure you cover the range, right? So they're both numerical. Both axes are numerical. They have to be labeled accordingly. So once the axis is prepared, now we can draw a scatter plot. And it's very easy. Like I mentioned, we have 10 women. This is the first woman. This is second. And this is the third. Every woman will have a location in the XY plane. And the location is the coordinate with value of X and the value of Y. And that's simple. So for example, for first lady, the metabolic rate is 36.1. So 36.1 will be around here. And Y is 995. So 995 will be close to 1,000. So around here. If you have a ruler, it will be very easy to identify the point, right? So this is our first individual. And the second individual will be 54.6 and 995. So, it's going to be the same on Y, but the x-axis become 54.6. So it's going to be around here. And then the third individual, 48.5, 1396, 48.5 around here. And 1396, about 1400. Okay, so roughly. And then next one, 42, 1418, 42 around here. And 1418, that's around here. So kind of around here, okay? And then 50.6, 1502, 50.6, 50 is here, 50.6, 1502, 1502. Okay, around here. And then 42, 1256. This is 42 right here. 1256, 1250 is here, right? Okay. And next point is 40.3, 1189, 40.3, 1189. Okay. And then 33.1, 913, 33.1, 918. Okay. And then 42.4, 1124, 42.4, 1124. Okay. And then 34.5, 1052, 34.5, 1052. That's very close to 1050. All right. So once all the individuals has a a location identified in the XY plane, then the scatter plot is done. So you have 10 individuals, you should have 10 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? And that's your scatter plot. So we know how to draw a scatter plot, right? So now why do we draw a scatter plot? What can we learn from the scatter plot? So anything that you learn from the scatter plot is about relationships. So what kind of feature about the relationship can you observe from the scatter plot, right? So the first thing is relationship form. So what kind of major trend do you observe from the scatter plot? And the form, basically, you're going to look at the majority of the data trend. So for example, the majority of the data trend is something like this, right? So apparently the form is going to be a linear form. Okay, so the form could be linear or nonlinear, but you have all different kind of nonlinear relationships. Okay, but we're going to focus on linear relationships. Relationship form, that's very easy to obtain, right? And next thing is relationship direction. So basically, if you learn in a math class, even when one variable increase, when x increase, if y increase correspondingly, that means they're going the same direction, right? So for that direction, we call it a positive relationship. And if x increase, y will decrease, that will be negative relationship, right? And of course, this is a positive relationship, right? The slope is positive. And the next thing we can find is relationship strengths. So we know there is a relationship, but is it a strong relationship or is it a weak relationship, right? So here is related to a term called a deviation. The deviation is the distance between the scatter points to the form in y direction, okay? So this distance is called a deviation, okay? So then for every point, there will be a deviation, right? And this point deviation is almost 0. And some deviation are positive, some deviation are negative, right? So then how do we evaluate relationship strengths? We're gonna look at the total amount of deviations, okay? So if the total amount of deviations are small, which means the points are close to the proposed form, right? Then for that kind of relationship, we call it a strong relationship. And on the other hand, if the total amount of deviation is big, basically the points are far away from the proposed form, then we call those kind of relationship as a weak relationship, right? So for this relationship is kind of strong. You know, strong or weak are always a relative term. And if you are able to compare two scatter plot, it will be easy to identify, you know, which one is stronger, which one's weaker. Okay, but you know, strengths, total amount of deviations. And next thing we can get is from the relationship, from the scatter plot, is a relationship outlier. So in statistics, we always need to pay attention to outliers for a single variable, also for relationship. So we mentioned every point will have a deviation, right? But if there are one or a few points that has extreme amount of deviation to the proposed form, the proposed form is, you know, the form you observe from the major data trend, right? If the deviation is huge for one or a few points, these individuals will be considered as outlier, right? So when you look at the coordinate, you know, when you look at the data, this will be the value with the coordinate 54.6 and 995, right? So whoever that lady is different from the, you know, the rest of the ladies, right? So that will be considered as outlier. So woman with measure of 54.6 and 995, that will be our outlier. Right? So scatter plot is very, very useful. From the scatter plot, we can identify the relationship features very quickly, you know, compared to, you know, when you look at the data set, right? So it's very, very quick and convenient way to describe the relationship. There are four features we look at all the time. One is the form, that's the majority of data trend, and then direction, positive or negative, strengths, you know, strong or weak. When you evaluate the strengths, don't include outliers. Just look at the majority of data trend to see if the relationship is strong or weak. And then outliers. So that outlier will be the individuals with the extreme amount of deviation compared to the others, right? It has to be extreme, okay, for outliers. So then with different kind of scatter plot, you can kind of see different, you know, relationships, right? So for example, when you have a scatter plot like this, you can see it's very strong, right? And it's positive. It's a linear relationship. And here it's a little weak, but still positive and a linear relationship. And this is, you know, you couldn't find any kind of a good relationship in there, right? So there's no relationship. And here you have a pretty weak, but it's a negative linear relationship. And this is pretty strong, right? But it's a negative and it's a linear relationship, right? So positive strong linear, positive weak linear, and no linear relationship, negative weak linear relationship, negative strong linear relationship, right? So we can kind of see if the two variables related. So this is how we describe linear relationship using graphs. But sometimes we want to compare, you know, if one relationship is stronger than the other, right? For example, this one, which one is stronger, right? It will be hard to compare using graphs. So if we can quantify that linear relationship, it will be a lot better, right? Because quantified number, we can compare number very easily. So then we need to define a measure to describe the linear relationship, and that's called correlation. Okay, so the correlation is a measure we can calculate from the sample to describe the linear relationship, right? So the correlation symbol is R, you know, that's in the list of all the symbols, and it can be calculated, and this is the formula to calculate. We're going to talk a little bit later about how to calculate and explain the formula. We're going to look at the features of the correlation first. So for There are a few general rules about correlation that, just common rules. You need to realize it if you want to study correlation. First, correlation is always going to be a number between -1 and +1. You can never see a correlation that's beyond a range. That's not possible, okay? So then next thing is, for any correlation value, the sign of the correlation, the positive and negative sign, that will tell you the direction of the linear relationship. So if the sign is positive, that means the relationship is positive. If the sign is negative, the relationship is negative, right? And that's pretty simple. And the next thing is the value of the correlation. So just ignore the sign. Just look at the value. So negative 0.5 and positive 0.5, they have the same value, right? So that value will give us the strength of the linear relationship. So how strong it is, okay? So the value of the correlation give us the strength, the sign of the correlation give us the direction, okay? Then which side is strong, which side is weak, right? So if a correlation is between -1 and +1, if you ignore the sign, the correlation value will be between 0 and 1, right? So then 0 is the weakest relationship, 1 is the strongest relationship, right? So if correlation value is close to 1, you have a strong relationship. If it's close to 0, you have a weak linear relationship. And next thing is, correlation is not affected by when you're changing the units of measurements. So for example, for the example in here, right? If you measure the lean body mass using kilogram here, if you change it in pounds, or you change it into grams, and it's not gonna affect the correlation value. So when you change the measurement units, the correlation is not going to be affected. And lastly, correlation is not resistant. We know what the resistant means, right? So when it's not resistant, that means it will be affected by the existence of outliers. Okay. So we know what the correlation is. The sign tells the direction and the value tells the strength, right? So for any correlation value I give you, for example, if I say correlation R equal to -0.9, can you tell me what kind of relationship it is? Right? So look at the rule. We have the relationship direction is negative. The relationship strength is 0.9 is close to 0 or 1. Close to 1, so it's a strong, right? And correlation is a measure of linear relationship. So put it together. If R equal to -0.9, we have a negative, strong, linear relationship, right? So what about if correlation R equal to -0.3? So what kind of relationship do we have now? So it's negative, weak linear relationship, right? Okay. So that's correlation. Now, we know what the correlation is, but how do we calculate it from the sample, right? So now we're going to look at a formula here. So the correlation is a product of two fractions. So you have a fraction here, you have a fraction here, right? And the first fraction is very simple. 1 over a -1, right? That's very simple. N is sample size. How many individuals are there in the data? That's N. So 1 over a -1. That's very easy. So here we have Sx and Sy. They're S with a subscript to tell you, to differentiate. You have two different S's, right? So what is S? What does S represent? If you go back to the list of the symbols, S is sample standard deviation, right? So you need to understand, all the symbols so that you can read the formulas correctly. Okay, so as a standard deviation, and x and y, basically that's the two variables we're trying to study, right? You're studying the relationship between variables x and variable y, right? So we already know how to calculate standard deviation. We just need to calculate standard deviation for variable x and the standard deviation for variable y separately. And then, we can plug it in here, right? So then the only thing that bothers us a little will be the summation piece on top, right? Sum of xi minus x bar, yi minus y bar. So the whole thing in the summation is a cross product term, xi minus x bar, yi minus y bar together, and that's being summed, right? So recall earlier when we calculate standard deviation, we calculated the sum of xi minus x bar squared using the worksheet. And that helps us a lot because it's organized. And for any summation, we can use the same approach. We can use the worksheet to calculate this top summation, and we can plug into the calculation afterwards. So let's look at a small example about how to calculate sample correlation. So suppose we have values x and y, they're given. It's a small data set. When x equal to 1, y equal to 4 for first individual. Second individual, when x equal to 3, y equal to 6, and 5, 7, 7, 10, and 9, and 13. So we have all the formulas we learned so far: mean, standard deviation, correlation. We need to use all of them. So to calculate correlation, we need to make a worksheet. It's going to be a little bit bigger than the worksheet we had before, okay, because we have two variables instead of just one variable. Okay. So to start, we're going to put the corresponding values, x and y's, into the worksheet as a start point. So 1 and 4, 3 and 6, 5 and 7, and then 7 and 10, and then 9 and 13. Okay. So then just like before, we can calculate the column total for some of the columns that we need. So for example, for the first column, we can calculate the column total by adding them all up, right? So 1, 3, 5, 7, 9. That's 1 and 9 is 10, 3 and 7 is 10, 10, 10, and 5, that's 25. Then just like, when we calculate standard deviation, we mentioned any column total is the corresponding summation, right? So this is adding all the x's up. So that will be sum of xi, right? So you can see sum of xi will equal to 25. And then from here, we can calculate x bar by the formula of x bar equal to sum of xi divided by square root of n, right? And that's pretty simple. I'm going to copy the fraction function here. So we know on top, sum of xi is 25. We just find out. And what is n? Is n equal to 5 or 10? N equal to 5, right? So you have 5 individuals here. For every individual, you have 2 measurements, right? You have 10 numbers, but it's only 5 individuals, right? Okay. And then likewise, we can calculate the summation of yi, right? By adding up all the y's. 4 and 6 is 10, 7, 13 is 20, 20 and 10 together, that's 40. Okay, so then for this summation, for this column total, it will be also a summation, right? But it's not going to be summation of xi anymore. It will be summation of yi. So summation of yi from the worksheet, we can get x equal to 40. Then likewise, the sample mean for variable x, we can calculate like here. we can calculate sample mean of y using the same equation, right? So this is going to be y bar will equal to sum of yi divided by n, right? So if we calculate, I'm going to copy the function here and change the number. So on top, sum of yi equal to 40, we just find out. And n is the same, right? You have one, you have the same sample size for, you know, the steady, right? So y bar equal to 8. I'm going to put this on top. We're going to need more space later on, okay? So then that will be the two number we're going to enter for the next two column. X bar equal to 5 all the way from top to bottom, y bar equal to 8 from top to bottom. All right, so now we're going to continue. Xi minus X bar corresponding x's minus X bars, right? So for the first one is 1 minus 5, that'll be negative 4. And then second is 3 minus 5, that's negative 2. And then 5 minus 5 is 0. 7 minus 5 is 2. And then 9 minus 5 is positive 4. Then yi minus y bar, that will be yi column subtract y bar column, right? So 4 minus 8, that's negative 4. 6 minus 8, that's negative 2. And 7 minus 8, that's negative 1. And 10 minus 8, that's positive 2. And then 13 minus 8, that's positive 5. And then what we need in a calculation is we need to get a summation here. Sum of xi minus x bar times yi minus y bar. If we get that summation calculated, then our job is almost done, right? This is the only piece we need because we already learned everything else. So we need to find what this is. And just like this is sum of xi, this is sum of yi, right? If we have a column xi minus x bar, yi minus y bar as a column, then the column total of that will be the sum of xi minus x bar, yi minus y bar, right? So that's why we create a column here. If you calculate all the numbers in here, the column total will be sum of this, right? Okay, and how do I fill this part out? So xi minus x bar from here, yi minus y bar in here, right? And this is a multiplication in between, right? So all we need to do is multiply the corresponding values here. So let's go ahead and do it. Negative 4 times negative 4, negative and the negative become positive, right? So here you need to pay attention to signs. Negative 2, so 2 negatives become positive, positive 4. And 0 times negative 1, 0 times anything equal to 0. And then 2 times 2 equal to 4. And then 4 times 5 equal to 20, right? So then this is done. We just need to add it all up, right? Add all the numbers up. So it's 20, 20, and 4. We have 44. So problem solved. The summation of xi minus x bar, yi minus y bar equal to 44. So then if you want to calculate correlation, we can already plug in some numbers in there. So let's plug in the one we already know. N equal to 5, right? We have 5 individuals in the data. And the top summation equal to a number I just found, 44. So we just need to find standard deviation of x and standard deviation of y, then problem solved, right? So now how do I find standard deviation? And that's from the previous class, right? Standard deviation calculation is the formula right here. So we need to find the sum of xi minus x bar squared. If we're able to find this, then standard deviation, we can just plug into the calculation, right? So we can use the same worksheet here to get this column total, to get this summation. So basically, sum of xi minus x bar squared will be the column total for xi minus x bar column, xi minus x bar squared column, right? So then xi minus x bar square column will come from xi minus x bar, take a square, right? So then for this column, we take a square over here. So -4 take a square, +16. -2 take a square, +4, right? So please be careful about the signs. And 0 take a square is 0, 2 take a square is 4, and 4 take a square is 16, right? So then problem solved, right? So just added the up for this column is 20, 20, and 0, so it's 40. And that will tell us this column total will equal the sum of xi minus x bar squared, which is 40. And then from here, we can calculate standard deviation of x, right? Just like what we learned last class. So I like to have the formula written out before we plug in numbers. That way, you can always compare if you plug in the numbers correctly. You try not to just plug in a number directly because a lot of times you confuse yourself, right? So you can match, the top summation is 40 and n is 5, right? So now we calculate. This is algebra. So 40 divided by 4 is 10. Square root of 10 is 3.16. So that's standard deviation of x, right? So we already got standard deviation of x here. That's going to be 3.16. So we just need to find standard deviation of y, right? Anyway, now this should be done using the same approach, right? I'm trying to get a little bit more space. All right, so let's squeeze it down there. Anyway, so we can find the standard deviation of y using exactly the same approach. So if you can find summation of yi minus y bar square. So if you change all the x's into y, then we should be able to find standard deviation of y, right? And yi minus y bar square, we can make a column of that. The total, column total will be that summation, right? So this column total will match with this summation. So then how do I fill this up? This will be yi minus y bar column, take a square, right? So y minus y bar, take a square. So from here to here. So -4 take a square, +16. -2 take a square, +4. -1 take a square is 1. And then 2 take a square is 2, is not 2, sorry, it's 4. And then 5 take a square is 25. Right? So we can calculate the column total here very quickly. 25, 29, 30, 30 and 20, this is 50. So then this will equal 50. Then we can calculate standard deviation of y very similarly with how we calculate standard deviation of x. All we need to do is just change the corresponding part from x into y, right? So then the summation of yi minus y bar square equal to 50, we just find out. So that need to be 50. So now it's 5 minus 1, right? And it's 5 again. So then we need to calculate this. It'll be square root of 12.5. You can use a calculator. And from calculation, it will equal to 3.53. Okay, so you got standard deviation y calculated. So this is standard deviation of y. So now you get the last piece you need, right? Standard deviation y will be 3.53. And then you have everything you need for correlation calculation, right? So just plug in everything together. So we're going to calculate this real quick. And it's 0.986. Okay, so that's the correlation between the two numerical variables x, y, and this is how we calculate it. Again, you need to understand how the worksheet is produced. And I'm not going to ask you to generate a whole worksheet for in the exam, but I will mask some of the values out. So as long as you know how it works, it shouldn't take too much of your time to to produce the worksheet and then do the corresponding calculations. So these calculations afterward is very important, and it's not that bad, right? The biggest thing is all the column total is corresponding to a summation function. The summation will be the corresponding summation of the titles, right? For example, you can have some column total here, but we're not interested in those. We don't need them in any of the calculations, so we don't have to calculate it. Okay. And if you're interested, this is not required. You can verify your results using some softwares for correlation calculation. So for example, you can put the numbers in here in Excel, and Excel can calculate the correlation very quickly. So correlation, and then correlation function has two arguments. The first argument is the number in X, and then second is the number in Y, and you hit enter, you can see, it's very close, right? Just because we have rounding errors when we calculate manually, and the software doesn't carry, doesn't have rounding issues. They're gonna carry all the decimals they need. So this is how we calculate correlation. And of course, when correlation is 0.98, we can tell the relationship is positive, strong, linear relationship, right? Okay. So we're going to look at an example. A study looked at the relationship between the knee height and overall body height of 6 adults, and the data are shown below in centimeters. The centimeters is the units we use for both knee height and overall body height. So first, we need to make a scatter plot and examine the main features of the relationship. This is only 6 points, but you can still see a pretty good linear relationship, and the direction is positive, right? Okay. So then from the scatter plot, you can tell the relationship, direction, and the strength, right? So it should be related to the correlation with that we calculated from the data. So based on the scatter plot, can you kind of guess what correlation value it should be? The strongest correlation will be 1, right? So what would be the strongest correlation look like? So basically, you're gonna have, let me use a paint. Okay, so what is the strongest relationship look like? Basically, you're gonna have a few points. If all the points land exactly on the linear form, then that's the strongest correlation, or equal to +1. And another strongest linear relationship, it could be all the points are on the form, right? So the total amount of deviation is 0. That's the smallest it can get, right? It cannot get less than 0 of the deviations, right? So correlation is strongest as well. In this case, R equal to 1, right? Okay. So now, of course, if the points are far away from the form, then the correlation will be weaker, will be getting closer to 0, right? So then, based on the scatter plot we observed here, can you guess what kind of correlation it would be? Of course, this is a positive correlation, right? So it should be between 0 and 1 somewhere. What would it be? 0.5, 0.7, 0.9, or something else, right? So just kind of a guess. And then we can verify. So now let's go ahead and calculate the correlation. So we can replicate the same process as we just did over here, right? We can generate a worksheet, and from the column total of the last 3 columns, we can calculate the correlation eventually. Same process. We can calculate the correlation as 0.89. Is that close to what you had in mind? It's okay, when you didn't guess right in the beginning, because, this is probably the first time that you learn about a correlation. It will surprise me that you can, you can match them that well. It take time and take practices to get familiar with the relationships, and then, you're going to get a better and better estimate, right? So then this is it for correlation, a scatter plot correlation. So we need to understand, we can describe relationships between variables. And the easiest relationship is a linear relationship, and that's what we're gonna, study, we're gonna focus on. So scatter plot can show us the relationship, the linear relationship from graph. But we can also quantify that linear relationship using a numerical measure that's called correlation. Okay? So correlation is always between -1 and +1. There's no exceptions. Okay. So anytime we ask you to calculate the correlation, make sure it's between -1 and +1. Otherwise, automatically it's not correct, right? So for correlation, the sign of the correlation will tell us the direction of the linear relationship, while the value of the correlation will tell us the strength of the linear relationship, right? And then correlation is not resistant. So if there is outlier, correlation will be affected. I believe you have a homework. You can kind of verify that. And also correlation is not affected when you change the units of measurements. And that's it. So, please send me any questions if you struggle with any concept mentioned. So this is about describing relationships. We can use a graph, scatter plot. We can use a numerical measure, correlation, and they should be consistent, right? Okay, thank you.